Hello guys, welcome to Bugs in Code. The problem that we are going to solve today is cutting rectangles. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel so that you never miss out an update. So let's get started. Here's the problem statement, and it says that hey, you're given a rectangle of dimensions L cross B. Find the minimum number n of identical squares of maximum side that can be cut out from the rectangle, okay, so that no residue remains in the rectangle. Also find the dimension k of that square. Okay, so one example is also given here, and let me just explain this example. So let me explain this example, and the example says that you're given a rectangle of length 2 and breadth is equal to 4, and you have to divide it into squares of equal side. Okay, so let me do it. What I'm going to do is I'm going to have a rectangle. Which is going to have like the length as 2 and the breadth as 4. Okay, so I have to divide this rectangle into squares of equal sides. So what I'm going to do is the first square that I'm going to take is like this square. So this is the first square that I'm going to take, and after that the second square that I can take is this square. So I can cut it into two squares of size 2 cross 2 so that no residue remains. So what I'm going to return is total number of squares that I'm going to have, which is 2, and the size of the dimension of one square, which is 2 cross 2. So I'm just going to represent it using single 2. So this is something which is going to be my output. I hope you guys are clear with the problem statement and the example. So let me just now move to the solution. So what I'm going to do is I'm going to take an example first where I have length as 4 and breadth as 6. So let's take a rectangle of length 4 and breadth is 6. So this is going to be a rectangle, and what I'm going to do is I'm going to take this. Okay, now what I'm going to do is I have to divide this rectangle into identical squares. So the length of this rectangle is 4 and the breadth of the rectangle is 6. What I'm going to do is I'm going to divide this rectangle into squares of size 3 and 3. Let's do it. So the first square that I have is this one, and the second square that I'm going to have is this one. And is there any other possibility? No, there is no any other possibility. But the problem with this is I'm having some residue. So I'm having some non-relevant residue here, and I don't like, I should not have this part left when I cut the rectangle. So in order to achieve this, what I'm going to do is I have to divide the rectangles in such a way that this length completely gets divided and this breadth also completely gets divided. So what I have to do is I'm going to write my first observation here, that find a number I'm going to find a number which is like, find a number which completely divides L and P. So this is my first observation, because you can see here that if 4 and 6 is not getting completely divided, then the problem is I'm going to have some residue left, and the problem says that you should not have any residue left. Okay, and second observation that I can make is I have to find the minimum number of squares with the greatest side. So how I'm going to do it? Like, you can see the problem statement, it says that you should have the minimum number of rectangle with the maximum side. So how to get this maximum side? In order to have this maximum side, I'm going to maximize this number. So I will rather say that find like I have to maximize the side of square. How I can do it? I can do it by maximizing this number. So rather I will call that find the greatest number. Find the greatest number which completely divides L and B. So if you notice this line, like if you notice this line carefully, then you will find that this line is nothing but saying that, hey, can you find the HCF or GCD of length and breadth, isn't it? So because HCF is something which is the highest common factor, so it is highest common factor, and GCD is also greatest common divisor. So you can say anything, but the meaning is same. The meaning says that you have to find the greatest number which completely divides L and B. So what I'm going to do is, if I find the greatest number which completely divides this 4 and this 6, so I'm going to have the side of my square, side of square. How? Like let's check for this. So if I check for this, then GCD of 6 and 4 is nothing but 2, and it says that if I divide this rectangle into side of 2, then I'm going to have no residue. Let's check. So if I take this one, like this is my first square, and this is my second square, and this is my third square. So yes, it is true that I'm not having any residue in the column side. Let's check for row. So I'm going to have my first square here, and I'm going to have my second square here. So even in the like rows, I'm not having any residue left. So yes, this statement is true, and I can just find the GCD. And even since this is the greatest common divisor, so I will surely have minimum number of rectangles. Now the question is, the first thing that I have noticed that we are going to have is GCD of L and B. So it is going to give me the side like dimension. But how to find number of squares? What about number of squares? So in order to find the number of square, what I'm going to do is, if you see this one, so you will find that the total number of cell here, since now the problem becomes easier because we are given the bigger square and we are given a smaller square, and we have to find that how many smaller square can be fit into this bigger rectangle. So it's quite simple. How I'm going to do is, I'm first going to count all the cells. So count all cells in rectangle. After that, I'm going to count all cells. After that, this first step, the second step is count all cells in the square, and then just divide them. So if I do something like 1 divided by 2, then it is going to give me number of squares. Like how? If I see here, so I have total 24 cells, and the cell, the number of cell in one particular square is nothing but 4. So if I divide them, I get 6. Means it means that I have to copy this square 6 times in order to cover this whole rectangle, isn't it? So this is what I'm going to do. So number of square is nothing but count like count of cells in rectangle and count of cells in one square. Okay, so I hope you guys are clear with the intuition behind the solution, and now I'm just going to write this solution. So let me just code this, and this is the problem on Geeks for Geeks, and now I'm just going to code this. Okay, so what I'm going to have is, first of all, I'm going to have my k as, k is nothing but the dimension that I have to return here, as you can see in the output. So my k is going to be GCD of length and breadth. After I have found the GCD of length and breadth, I'm going to find the total number of rectangles, total number of actually squares, which is going to be log of L cross B, which is the total number of cell in the rectangle, and then I'm going to have the total number of cell in the square as k cross k. So I'm just going to return arrays dot as list n and k. Okay, so let me write the function gcd, how we are going to calculate the gcd. So I'm going to have now l and going to have down b. The first thing that I have to do is, okay, so let's have some discussion about how to find gcd. So this is our screen, and what we are going to do is we are going to start with like GCD, how to find it. So you have seen a very famous method, which is Euclidean method, to find the GCD. So if I have something like 16 and 20, what I'm going to do is I'm going to divide this 20 by this 16, and after that, uh, what I get is I get here 16 1 times 16, and then I will remain with 4, and then I will write 16 here. Now my 16 become dividend, and this remainder becomes my divisor. So it gives 4 times 16 and it becomes 0. Now at last I have this divisor as my answer, as my GC, or I will say GCD. So how I'm going to implement it using code? What I'm going to do is, first condition that I'm going to check, if my let's say it is a, let's say it is a and it is b. Now it becomes easier. So if my a is small, like smaller than b, then the first thing that I will do is I will call my function f. So let's say f is my function, so I will call my function for b and a, like I will swap them, so that my first becomes greater, like it is dividend and it is divisor, second one is divisor. Now what I'm going to do is, if anytime my divisor becomes 0, like b becomes 0, why I'm checking that, you can see that, then what is the next step of when we do this? When we do this, we call a function for like this 0 and this 4, isn't it? So here I can see that my divisor becomes 0, so at that time I'm going to return my dividend. So I'm going to return a. Now what I'm going to do is, as you have seen here, what I'm actually doing is I'm calling my function for, now here you can see that my divisor becomes my dividend, so b will become the dividend, and the first one is always dividend. Like if I do something like this, then I'm going to take this as dividend and this as divisor. So it is going to my dividend, and my divisor is now going to be the remainder of the division. Like this is a divided by b, so whatever the remainder is after division, so it is going to be my new divisor. So this is what I'm going to write in the code. So I've just given you a very brief explanation, and let me just now to move to the code. So here what I'm going to do is, I hope you guys have noted whatever I was saying at that point, and I'm just going to code it here. Okay, so let's wait for some time because my laptop is not working now. Okay, so now just talk about the solution. What I'm going to have here is, I'm going to do, if my L is smaller than B, then I'm going to return GCD of B and L. Why I'm doing this? Because I want my L to be greater as it is a divisor. So if my B becomes 0, like it is my divisor, then I'm going to return L, which is my dividend. After that, I'm going to return GCD of, okay, so it is going to have return type long, which I have not written here. So after that I'm going to return B here and L mod B here. Let's check whether it works or not. So let me run this. Okay, so it's working for example test case, and let me just submit the solution. Let's see whether it works or not. Okay, so you can see that this code is working, but what I want is, I want to make this function as iterative function. Why I'm making is this iterative? Because you can see it's recursive and it can cause stack overflow error. So what I'm going to do is, while my b is not equal to 0, while my b is nothing but my divisor. So while my divisor is not equal to 0, what I'm going to do is I'm going to have my L as b and my b as L mod. Okay, it is going to be L mod b. But the problem is when I have changed the value of L, then I can't use this value here. So what I'm going to do is I'm going to return first store this value somewhere, and after that I'm going to return here temp. And now at last I'm going to return L, because since my b is 0, so this is the base case. If my b is 0, then L is going to be the answer. And I can surely say that there will be one point when my b will become 0, because every two numbers have at least one as their greatest common divisor. So okay, so it is also working, and this is all about this problem. It was a kind of easy problem, and I have explained you uh, the intuition behind the solution and both iterative and recursive solution. So this is all for now. Thank you.